composition. So before we start with chemical composition, we have to do a little bit of review. The first thing we're going to review are oxidation numbers. Okay. Oxidation numbers tell us the number of electrons in an atom that it needs to gain or lose to make it the complete octave. So, tells number of electrons in atom needed to gain or lose to make complete. And of course, by complete we mean to make the octave, so the octave rule and everything. So, our steps to finding the oxidation numbers. So, we'll start with the element, and then we're going to have its total number of electrons, which we find by looking at the periodic table. And then its valence electrons, which we know by the group that it's in. And then we'll be able to determine how many it gains or loses to be able to form the octave rule and to make it complete. And by that, we will know the oxidation number of each of the elements. So first off, we're going to use sodium, which is Na. And the total number of electrons for sodium is 11. And its valence electron is 1, and it's going to lose 1. And so we know that it loses 1, so that means that it's going to be plus 1, because I know it's lose, but we do the opposite of what it sounds like. So then our second one is going to be oxygen, which is represented by O, and its total number of electrons is 8, and its valence electron is 6, and so it's going to need to gain 2 to make this number the octave. So to make it complete, it needs 2 to make it 8. So it needs to gain 2. So the oxidation number is going to be minus 2. The next element that we're going to use for the oxidation number is aluminum, which is represented by Al. And its total number of electrons is 13, and its valence electron is 3, and so it needs to lose the 3 to make it 0 to make it complete. So it needs to lose 3, and so then after losing 3, so because it's lose 3, so it's plus 3 as its oxidation number. So this is how we find the oxidation numbers, which is just the first step in reviewing for chemical composition. Next, we're going to learn about nomenclature. Now for nomenclature. Alright, so nomenclature for compounds, we have two different kinds of compounds. We have ionic and covalent. And first we're going to work with the ionic compounds. So for ionic, you always write the metal first. You have the cation and the anion. The cation is the metal. For the cation, you use the same name that it's given on the periodic table. So the element is the same as the element. So lithium plus would be lithium. And then we have a list of all the cations right here and all of their names. They're going to be the exact same as what's on the periodic table. Alright, and for the anion, we're going to use its root element name and then add IDE. And we have all the anions and what their root name with IDE looks like. So how do you name them with those? Alright, so now that we know what the cation and anion are, we know that when we name them, we just put the cation and the anion names together. So, for example, we have aluminum bromide, which will be written as aluminum bromide, so AlBr3. And when you write it out, compounds are always written in lowercase. We never capitalize it like we do in the formula. Next, we're going to do covalent. Now for the nomenclature of covalent compounds. So first we're going to name the less electronegative element of the two that we're given. And so to do that, we're going to use table S in our beautiful reference packet. So the first element, once you find which one is less electronegative, the first one is going to be written just as its name that is given on the periodic table. And then the second one is going to be written with its element name root, and then we're going to add IDE, kind of like we did for ionic. And then when we're naming it out, be sure to include the prefixes, which tells us how many of each atom is in the element for the compound. So like if it's H2O, we know that there's 2 H's. So for prefixes we have over here, 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is oxa, 9 is nano, and 10 is deca. And now for the nomenclature of transition metals. For transition metals, we have to be sure to include the oxidation number when we're naming the transition metals. So we use Roman numerals to indicate what the transition metals oxidation number is. So for example, in this equation, CuCl, we're going to take these and we're going to check the oxidation numbers. And we get CuCl, and copper is what Cu is, has an oxidation number of 1. So then we're going to write the equation, or written out as copper 1 chloride. And then for Fe2O3, we check the oxidation numbers, and then we write it out as iron 3 oxide. Next, we're going to go over the 5 equations. And now for the 5 types of reactions. Our first type of reaction is synthesis, which means combining or joining. And it occurs when 2 elements combine together to make one compound. Our type is called A plus B yields AB. And an example is C plus O2 yields CO2. Our second type of reactions is decomposition, which is when a compound breaks down into elements or into smaller compounds. The type is AB yields A plus B. And our example is HGO yields Hg plus O2. For these, we can have catalysts. Catalysts are substances added to a chemical reaction to help the reaction occur. One example is heat, which is represented by a triangle over the yield sign. Our third type of reaction is single replacement, which is where one element gets replaced in the compound. A metal can replace a metal, and a non-metal can replace a non-metal, but they can't replace each other. The type is A plus B C yields AC plus B, and in this one we have A as a metal, B as a metal, and C as a non-metal. An example would be zinc plus AgCl yields ZnCl2 plus Ag right here. An important thing about single replacement is that we have to check table J in our packet for the reactivity. And the more reactive element can replace the less reactive element. And if the less reactive element is trying to replace the more reactive, then it won't work. Our fourth type of reaction is double replacement, which is where 2 elements are replaced. So it's like this, except 2 instead of 1. The type is AB plus CD yields AD plus CB. We have to be sure to check the solubility before replacing. When we check the solubility, if one is insoluble, then the reaction occurs. But if both are soluble, then no reaction can occur. So as an example here, we have AgNO3 plus NaCl yields AgCl plus NaNO3. And after checking the solubility of each of these and making sure that they go by the rules that we have here, we're able to realize that this equation does happen. So it says, yes, yay, that the reaction happens. And our fifth type of reaction is combustion. Combustion occurs when hydrocarbons, or fuel, react with oxygen gas. Combustion can also be referred to as burning. The 3 things that are needed to make combustion happen are oxygen, fuel, and our fuel are our hydrocarbons, and then a spark. The type for combustion is CxHy plus Oz yields CO2 plus H2O, always. An example of that would be C11H22 plus O2 yields CO2 plus H2O. And then when we have an acid and a base, it's always going to yield salt and water. Always, always, always. So, today we learned about oxidation numbers, nomenclature, and the 5 types of reaction. So thank you for sticking around for chemical composition.